Howdy folks, Mr. Reed here, and welcome to One More Question. So what we're going to be taking a look at today is the process of simplifying a radical expression. I'm going to do one that's a square root and one that's a cube root, and we're going to start out with an entire radical both times, which means we're going to have everything inside of the radical symbol, and we're going to take that to the outside so that it becomes the most simplified form of the radical. Which means that there will be the smallest number that you can leave inside of the radicand, or the number that's inside of the radical symbol. So if you want to see simplifying radicals, you're in the right place. Let's get to it. Okay, so I have a couple of examples, as I said before. One of them just so happens to be the square root, and one happens to be the cube root. My Apple Pencil wasn't picking up, so bear with me for just a moment. We're going to hope it has enough juice to go. All right, now, let's take a look at that square root of 48 first. Now, if I don't give you any kind of like nuanced approach to this, if we just want to take this and break it into, or make it into the simplest form mixed radical, then the way that I'm going to do that is I'm going to take advantage of the fact that if I have a radical that can be written as the product of two different pieces inside, it's actually true that we can take that and split it up into the same type of radical of each of those different factors separately. So we're going to look for factors of 48 that are perfect squares. Actually, we're going to specifically look for the largest factor of 48 that is also a perfect square. So if I were to list all the factors of 48, it would be 1 times 48, 2 times 24, 3 times 16, 4 times 12, not a 5, a 6 times 8, and we're good there. So in this list, I'm going to search for the largest number in this list that is also a perfect square. So it's not 48, it's not 24, it is 16, because 16 is 4 times 4. So what I'm going to do is I'm going to rewrite my 48 as a product of two factors that multiply to give me 48, which I'm going to take 3 and 16. Now, I probably should have written 16 and 3 because of the way I'd like to write it in the end, but it really doesn't matter. So because of this property that I probably, in terms of timeline, should cover in an earlier video, but I haven't done one on it yet, why it is the case that we can split things up like that, or at least kind of showing that it's possible. For now, I'm just going to assume that you either know that you can take these radicals and split them up into two, or you'll believe me for the time being so that you can get to trying to simplify them, and you'll look for the reason why either on your own or later on when I put a video out on that. So if we were to take that and split it into two separate radicals of each of those factors, it would look like this: root 3 times root 16. Now, the nice thing is that, I'm going to come way down here, root 16, the reason we picked it is because it is a perfect square. So we would get the square root of 16, which is 4, but we also get the square root of 3 still being multiplied by it, and the square root of 3 will not. We chose the largest possible square, so because of that, we're not going to get in any trouble here, I guess you could say. For this particular example, we have just the square root of 3. The only factors there are 1 and 3, so neither of which is a perfect sorry, I shouldn't say that. 1's a perfect square, but it's not going to change the look of it at all. So 3 is not, so we can't do anything else here. We get 4 root 3. This is the simplified form of this particular radical, and it is a mixed radical, a simplified one. So that is our first example. Next up, going to take a look at a cube root, which again is just a radical statement. Just a different type of radical. So this time we're looking for something that when multiplied by itself 3 times gives us 54. That is an irrational number, but this is not the simplest form of that particular irrational number. So again, I'm going to do a list of factors of 54. So this time, 1 times 54, and 2 times 27. Let's see here, 3 times 18, 4 is a no, neither is 5. 6 would be okay. and then 7 and 8 are both no. So that's the full list of factors there. Now, if I am to kind of comb my way through the factors this time, starting with the largest one again, I'm going to now pay attention to the largest cube because it's a cube root that I'm trying to do here. So the largest cube is not the 54, but it is the 27. 27 is 3 times 3 times 3. So I'm going to rewrite my original statement as the cube root of 27 times 2, which, using the same sort of idea that we can split apart these radicals. Now, it doesn't actually matter what type of radical it is, they actually split the same way. So you don't have to split this one into like 3 factors just because it's a cube root. We just split it into 2 pieces, each of which is a cube root. So we get the cube root of 27 times the cube root of 2. The cube root of 27, the reason why we did it this way is because we picked that 27 because it has a really nice cube root. The answer to that is just 3. And then the cube root of 2 is the cube root of 2. 2, again, 1 is a factor, but 2 is not a perfect cube, so it gets stuck in there. An irrational value overall still, but it looks like 3 cube root of 2. I put a little dot multiplier in between them on the line before. It's usually not written in there. It's just written like you would write an algebraic statement with a variable and a coefficient. So if you had 4 times x, you just write it as 4x. If you have 3 times the cube root of 2, you just write it as 3 cube root 2. So there we go. This is another simplified form of a radical. So we did it with a square root, we did it with a cube root. It's basically the same process both times, except for you're looking for the perfect either square or cube or nth power to go with your nth root that you're talking about. So if it was a 5th root, you'd look for a perfect 5th power. Hopefully you found that one helpful. If you did, like, subscribe, and as always, take care, folks.